Disruptive Technologies Section 5 Lesson 2 Advanced Oil and Gas Exploration and Recovery. After the first global oil shock during the 1970s, nations and energy companies around the world were forced to consider what the future with willing fossil fuel suppliers might look like. One response was to look for new types of fossil fuel reserves and develop ways to reach them. 40 years later, these efforts are finally beginning to pay off. Horizontal drilling and hydraulic fracturing, the technologies for reaching unconventional reserves such as the natural gas and light tight oil trapped into the rock formations, often called shale, are now at the point of widespread adoption. These extraction techniques have the ability to unlock both newly discovered reserves and previously known deposits that could not be economically extracted during conventional methods. From other side, global warming, increasing CO2 in the atmosphere, which is linked with melting sheets, a rising sea level and severe storms, and drought. Using alternative energies such as wind and solar will reduce emission of carbon in the atmosphere. American energy companies, particularly those in the United States, are furthest along in exploration and development of unconventional reserves and could maintain a sizable lead through 2025. Other countries are also believed to possess sizable reserves, but it could take many years to develop them. Globally, assessing these unconventional oil and gas resources could deliver significant economic impact by 2025. Shale gas production is already well underway and LTO is becoming part of the North American oil supply. These developments will clearly have an impact in the coming decade, which is why they are the focus of the analysis. However, they are not the only unconventional reserves. In fact, improved technologies could eventually unleash yet another fossil fuel revolution. Target for the drill bed is approximately a mile below the shale surface. This is very thin region of shale. This region contains the plants and other organic materials now turned into the gas. Geologists know for the years that shale can be converted into the gas. Normal well drilling is vertical, so the capturing the gas from the shells must be horizontal. Reason: the process is cost effective. well require several rings of pipe and cement to protect groundwater sources from contamination. Outer pipe is first ring of protection. Ring protecting gas to leaking out. Innermost pipe will conduct gas to the surface. Isolated wheel is critical. All layers are filled with cement to create additional levels of protection. Once the well is drilled, it's time to release shale gas with the process called hydraulic fracturing or fracking. First explosive charges is placed on horizontal sections of the pipe and create vertical fissures through the shale. Then water under the enormous pressure is pumped down the pipe and into the fractured shale. The water contains sand which helps props open the fissures and then allows the released gas to travel to the surface. Activity on the drill site is intensive. After 3 to 4 weeks of intensive drilling, we will have first results. Applications of advanced oil and gas exploration and recovery are important and complex. Not only are there opportunities for energy players and suppliers, but there could be also substantial impact on downstream manufacturing industries and consumers. For some countries, these newly available resources promise greater self-reliance, which could either their geopolitical postures. However, many citizens and leaders are concerned about the potential damage that hydraulic fracturing can have on local environments and ecosystems, leading some countries to ban the processing entirely. There are also concerns that unconventional oil and gas could affect the development of renewable energy sources such as solar and wind by making fossil fuels once again cheaper by comparison. Over the coming decade, businesses, societies and policy makers will have to decide how best to benefit from new sources of fossil fuels while managing risk and concerns. If unconventional reserves can be safely and cost-effectively exploited, the pattern of growing energy scarcity may be reversed for many decades. Unconventional oil and gas reserves are defined as reserves that cannot be extracted by conventional drilling methods. In these reserves, oil or gas is trapped in natural fractures in rock, often called shale, or absorbed by nearby organic material. Besides shale gas and LTO, unconventional fossil fuel deposits include coalbed methane, tight sandstone and methane clappers, also known as methane hydrates. Proven reserves of coalbed methane in Canada's Alberta province have been estimated to be equivalent to nearly 13% of world shale gas reserves, and methane clarite deposits are estimated to be many times larger than shale gas reserves. However, extraction of these reserves has thus far been difficult. The enormous methane clarite deposits are located on the ocean floor, making them too expensive to recover in most cases. Development of coalbed methane has been set back by falling natural gas prices due to shale gas availability in North America.